Let's pick up where we left off for the suggested homework exercises for section 2.3. And I'm going to need my calculator for this first problem, so that's why I have that out. So we're going to find the equation of the tangent line for the function f of x is equal to x over x plus 4 at the point negative 5, 5. We're going to do it by hand first. Then we're going to use technology to help us verify that. So f of x is u over v, where u is equal to x and v is equal to x plus 4, and u prime is 1 and v prime is 1. So f prime of x is u prime v plus minus v prime u all over v squared is 1 times x plus 4 minus 1 times x over x plus 4 quantity squared. So f prime of negative 5 is negative 5 plus 4 minus negative 5 over negative 5 plus 4 squared is negative 1 plus 5 over negative 1 squared is 4 over 1 is 4. So I have my slope, I have my point, so y minus 5 is equal to 4 times x plus 5. That gives me the equation of a tangent line of y minus 5 equals 4x plus 20, and y equals 4x plus 25. So let's go ahead and I have the equations in here already for those two functions. And let's find the point of intersection, second calc number 5, that it is this function here and this function here. And I guess I need to get a little bit better guess. This is kind of hard because they only touch at one point. So I'm just going to show it to you this way. Trace negative 5, 5 on the blue function, and negative 5, 5 is on the red function there. And so I'm going to go back to the blue function here, and I'm going to use the draw feature of the calculator here while I'm on the graph to draw a tangent line at the point negative 5, 5, and hit enter. And when x is negative 5, my tangent line is going to be 4x plus 25, which is what we calculated. And that's a feature in your calculator. Now, if I clear the functions here, sometimes the drawing will still remain on the graph. To be sure that it's gone, you want to second draw, clear draw to get rid of your drawings. So let's move on to number 69 here. And f of x is equal to 8 over x squared plus 4. And we want to find the equation of the tangent line at the point 2, 1. So u is 8 and v is x squared plus 4. U prime is 0 and v prime is 2x. F of x is u over v. F prime of x is u prime v minus v prime u all over v squared is 0 minus 2x times 8 over x squared plus 4 quantity squared is a negative 16x over x squared plus 4 quantity squared. F prime of 2 is a negative 16 times 2 over 2 squared plus 4 quantity squared, negative 32 over 4 plus 4 squared, negative 32 over 8 squared, negative 32 over 64 is a negative 1/2 for my slope. And then I have the point 2, 1. So y minus y1 equals m times x minus x1. Y minus 1 equals negative 1/2 x plus 1. Add 1 to both sides, and y equals negative 1/2 x plus 2. That was number 69. Let's move on to number 73, where we're trying to find a horizontal tangent line for the problem f of x is equal to 2x minus 1 over x squared. Again, I'm going to call this u over v, where u is 2x minus 1 and v is x squared, making u prime equal to 2 and v prime equal to 2x. F prime of x is going to be u prime v minus v prime u all over v squared, 2 times x squared minus 2x times 2x minus 1 all over x squared quantity squared. F prime of x is 2x squared minus 4x squared plus 2x over x to the fourth is negative 2x squared plus 2x over x to the fourth. Common factor of x in everything will be x times negative 2x plus 2. I'm going to pull out a negative 2x here, times x minus 1 over x to the fourth, and f prime of x is a negative 2 times x minus 1 over x to the third, and I want to find where that is equal to 0. So set equal to 0. So set the numerator equal to 0. That means x minus 1 equals 0, x equals 1. If x equals 1, they want me to find the y coordinate with that and give the ordered pair. That's 2 times 1 minus 1 over 1 squared. 2 minus 1 over 1 squared is 1. 1 over 1 is 1. So I have a point of horizontal tangency at 1, 1. Let's look now at number 83. Area with respect to time is given by the square root of t times 6t plus 5. I'm going to call that a of t is equal to 6t to the 3/2 plus 5t to the 1/2. And dA dt, where a is measured in square centimeters and t is measured in seconds, I believe. Yeah, in seconds, will be 18 divided by 2 is 9, t to the 1/2 plus 5/2 t to the negative 1/2. So that will be 18 t plus 5 over 2t to the 1/2, the square root of t, like that. All right. All right. And so this is in square centimeters per second for my unit. And let's look at number 86. Is P of t is equal to 500 times 1 plus 4t over 50 plus t squared. So I have P of t is equal to 500 plus 2000t over 50 plus t squared. And I'm not really worried about that 500 part because that's 0, but u is equal to 2000t, v is equal to 50 plus t squared, u prime is equal to 2000, and v prime is equal to 2t. So this is going to be u prime v plus v prime e minus v prime u all over v squared. It's equal to 2000 times 50 plus t squared minus 2 times 2000 t. 2t times 2000 t is 4000 t squared over 50 plus t squared quantity squared. P prime of t is equal to 0, 0, 0, 0, 10 plus 2000 t squared minus 4000 t squared over 50 plus t squared squared is 100,000 minus 2000 t squared over 50 plus t squared quantity squared. So now I'm ready to plug in when t is 2. P prime of 2 is equal to 100,000 minus 2,000 times 2 squared over 50 plus 2 squared squared is 100,000 minus 8,000. It's 92,000 over 54 squared is 2916. P prime of 2 is approximately 92,000 divided by 2916. And I'm going to round to the nearest hundredth here. So this is 31 and 55 hundredths bacteria per hour, given the units of each variable there. The P is a population of bacteria, and time is measured in hours. So this P prime is dP dt, if that helps you see units of population, bacteria, over units of time, hours. 86 is what we just did. let's move on to number 91. So now we're going to find second derivatives here. So number 91, f of x is equal to x squared plus 7x minus 4. F prime of x is 2x plus 7. F double prime of x, the second derivative, which is the derivative of the derivative, will be 2. Let's go ahead and look at 93. F of x is 4x to the 3 halves. So f prime of x is 12 halves x to the 1/2, or 6x to the 1/2. Second derivative, half of 6 is 3, x to the negative 1/2, or 3 over root x. 95. Is f of x is equal to x over x minus 1 is u over v, with u equal to x and v equal to x minus 1. U prime is 1 and v prime is also 1. F prime of x is u prime v minus v prime u all over v squared. F prime of x is 1 times x minus 1 minus 1 times x over x minus 1 quantity squared. X minus 1 minus x over x minus 1 quantity squared is a negative 1 over x minus 1 quantity squared. And we'll go ahead and prime of x is equal to a negative x minus 1 to the negative second. I don't think we've done anything like that there, so I'm going to leave it as is, a negative 1 over x minus 1 to the second, with my u being negative 1 and my v being x squared minus 2x plus 1. U prime is 0. V prime is 2x minus 2. F double prime will be u prime v minus v prime u all over v squared. It's going to be u prime v is 0 minus v prime u is a negative 1 times 2x minus 2. So that negative negative will make a positive. V squared, that was already x minus 1 squared, and I want to square that. So f double prime of x is 2x minus 2 over x minus 1 to the 4th, and so this is going to be 2 times x minus 1 over x minus 1 to the 4th, and x minus 1's will cancel. 2 over x minus 1 to the 3rd for my final answer for my second derivative there. That was number 95. Let's look at number 97 now. f of x is equal to x sine x is equal to u times v, u equal to x and v equal to sine x. U prime is 1 and v prime is cosine of x. F prime of x will be u prime v plus v prime u. So f prime of x is 1 times sine is sine. X times cosine is x cosine of x. F double prime of x is the derivative of sine as cosine. Now I have a u of x and a v of cosine of x. U prime is 1, v prime is a negative sine x. So this is double prime is cosine plus u prime v plus v prime u. Double prime is cosine plus cosine minus x sine. So that is 2 cosine x minus x sine x. That was number 97. Let's look at number 99. Is f of x is equal to cosecant x. So f prime of x is a negative cosecant x cotangent x. So that is a u times v, where u is a negative cosecant x and v is a cotangent x, and u prime is a negative cosecant cotangent times a negative 1 is cosecant cotangent. V prime is a negative cosecant squared. So f double prime of x is u prime v plus v prime u. F double prime of x is u prime times v is cosecant x cotangent squared x. And then same sign here. So that will be plus, because I'm going to have a negative cosecant times a negative cosecant squared will be plus cosecant cubed x. So let's look now at the next one, which is 101. We want to find higher order derivatives, given the first derivative here is x cubed minus x to the 2/5. We want to find the third derivative. So let's find the second derivative, which is 3x squared minus 2/5 x to the negative 3/5. And then the third derivative is going to be 6x plus 6/25 x to the negative 8/5. We could also write that as 6x plus 6/25x to the 8/5 if we want to eliminate that negative exponent. Let's look at number 103. if our second derivative is equal to a negative sine x, what is our eighth derivative? So our third derivative will be derivative of negative sine is negative cosine. Fourth derivative, cosine is a negative sine, so a negative sine is sine. Fifth derivative, derivative of sine is cosine. Sixth derivative, derivative of cosine is a negative sine. We're back at the top again. Seventh derivative is going to be the derivative of negative sine is negative cosine. And eighth derivative is the derivative of negative cosine is sine. Let's look now at number 117. And v of t is given as 36 minus t squared. T is between 0 and 6 seconds inclusive. Velocity is in meters per second. Acceleration will then be in meters per second squared. Time is in seconds. We want to find velocity and acceleration when t is equal to 3. So v of 3 is 36 minus 3 squared is 36 minus 9 is 27, and that'll be meters per second. And a of t, my acceleration, is my v prime of t, so that will be a negative 2t. A of 3 is negative 2 times 3 is negative 6, and that will be in meters per second squared. We have opposite signs here that velocity is positive and acceleration is negative. So what does that tell me? That tells me that I'm moving probably forward or to the right in a positive orientation for my direction of travel, but I'm decelerating. So the next moment in time, I'll be going slower than 27 meters per second. So I'm moving forward, but I'm decelerating. That's what happens with opposite signs. So it's like if this was negative and this was positive here, then it would be like if I were in reverse, but I hit the brake and I was moving towards 0 for my speed. Here I'm moving forward, and it's like I'm hitting the decelerator or the brake, and I'm decelerating. All right, let's finish up with number 120 here. And this one's a little challenging to see exactly where the x-intercepts are and things like that. So I'm just going to help you with this graph. You can try and zoom in on it. But let's first identify which function is which. So this cubic function right here is the highest degree. So that'll be my position function s. And this quadratic right here will be 1 degree less than this cubic. So that'll be my velocity function v. And this linear equation is 1 degree less than that quadratic. So that will be my acceleration function that I'll call a. So we've labeled it, copy the graph function, identify each graph. That's what I've done, S, V, and A, and explain your reasoning. It has to do with the degree of each one, that this is degree 3, degree 2, degree 1. On your sketch, identify when the particle speeds up and when it slows down. So let me actually kind of draw a new version here just with the the velocity, but I'm going to take the absolute value of it. So this is going to be speed. So it's going to then turn this way, and then it's going to go back up like this. So it has a fixed point here. It has a fixed point over here. So it is a negative slope. It is slowing down or decelerating. On the interval from 0 to, and then we're going to call that intercept right there 4/3 for 1 1/3 union, and then this intercept or this vertex, we're going to call that point right there 2, that looks like 2 1/3, or sorry, 1, 2, 2 2/3, 2 2/3 right there. So we'll call that right there x equals 8/3. We'll call this point right here x equals to 4/3, and we'll call this point right here x equals 4, and this will be over here, this endpoint right here will be x equals 6, and this point right here will be x equals 0, just so you can see what I'm talking about. So this is 0, then this is 4/3, then this is 8/3, and this is 4, and this is 6. All right, so we are slowing down from 0 to 4/3, and from 8/3 to 4, and we are speeding up from 4/3 to 8/3, and from 4 to 6. All right, that's it for this video, and we'll come back next time and we'll start talking about suggested homework problems from section 2.4. See you for the next video.